Hello, everyone, and a very warm welcome to this showcase session hosted by Nokia. My name is Ulrich Refus. I'm heading Spectrum Policy in Nokia, and I'm based in Munich in Germany. It's a great pleasure to present this afternoon a little bit on this future of industry, so spectrum and connectivity topics. I presume you've heard quite a bit yesterday in a session on private networks, and even just a session before this one on mid-band spectrum. So we hope to give you a few more insights, maybe from a pragmatic perspective on what is feasible today. May I have the next slide, please? So we have prepared this agenda for you. So we'd like to give you some impression with a short video on what is possible today from a product perspective, even for very small networks, and then certainly scaling to whatever is needed to cover large industry campuses. I would then go through a few examples of what we see in midband for spectrum access for local enterprise use, talk a little bit about the architecture models that there are in place for non-public networks, a few considerations on how cooperative models between mobile operators and such private entities for enterprise networks could look like, and then also look a little bit into what high band actually can offer on top of the C-band or mid-band options. And we would then present you live from our Berlin demo labs some demonstrations of how these industrial-grade private wireless networking solutions can look like. So with this, we'd like to start the video and see you in a couple of minutes. Thank you.
The Nokia Digital Automation Cloud Platform is a quick and easy way to create your own private wireless network. And we'll show you how to get connected in just 20 minutes. First, you'll receive a kit containing the Nokia DA access point, Nokia DA Edge, and the necessary cables. You'll also receive login credentials for the Nokia Digital Automation Cloud dashboard. In the dashboard, under the menu icon, click on the Networks and DA Edges link. Here in the Managing Equipment and Networks page of the dashboard, you can find the DA Edges, DA access points, and the SIMs you have purchased. Once you're in the Networks and DA Edges section, select a network and click Activate to create a private wireless network. A pop-up reminder is displayed so that you can give your network a name. Once you have named your network, click on the Save and OK buttons to complete the activation process. As you can see here, the name of the network and DA Edge have been updated, and the network is now activated. Also, a handy feature to note is that the DA access points are automatically added to the specific network which you have activated. Once the network activation is complete, your next step is to plug the Nokia DA Edge into a power outlet and turn it on. Then plug the Nokia DA access point into the power outlet and turn it on. Now check that DA Edge and DA access points are connected to the Internet. In the Networks and DA Edges section of the dashboard, you'll see that the SIMs you purchased are automatically added to an activated network. You can use these SIMs for multiple devices. The devices are now ready for use and can be monitored in the dashboard. The Nokia Digital Automation Cloud Platform also allows you to assign different capacity and quality of service for individual application needs, and these too can be effectively managed in the dashboard. In this simple setup, it took less than 20 minutes to build a secure wireless network and to start and manage a video application through multiple devices. Nokia Digital Automation Cloud, the quick and easy way to create your own secure wireless network. We create the technology to connect the world.
So, welcome back. I hope that gave a little bit of an impression how easy it can become nowadays to create even your own network. Key for any network certainly is spectrum access, and that's pretty much my domain. So I'd like to now guide you and introduce you to a few concepts that we see in the market and share a few thoughts on that with you. So on the next slide, you see one example from Finland in the C-band. So you may know that 4 to 38 gigahertz is one of these 3 European 5G pioneer bands, so providing ample resources for 5G in this mid-band range. So it had been quite debated how to actually assign that in terms of a split between mobile operators and for enterprise use. Finland chose a model where they, in an auction, assigned 130 megahertz each to 3 mobile network operators, but with certain provisions for subleasing to local enterprises where needed and appropriate. So for an enterprise, it could look like on this picture. So this enterprise would have the choice to contact any of these 3 mobile network operators for some subleasing agreements, and then getting access on a contractual base with one of these to like up to 130 megahertz. That would be covered by both the 3GPP bands N78 and N77, and thus give access to global ecosystems of devices. On the next slide, you would see the German path, which is a pretty different one. I guess also that had been introduced yesterday by Alexander Kühn in the conference. Germany decided to set aside 100 megahertz at the top of the band, also due to some legacy constraints, some legacy licenses that existed. But then also certainly to provide direct spectrum access for vertical enterprises in a local licensing regime. So there's an application procedure in place since November 2019, where enterprises can ask for access to up to 100 megahertz of spectrum there. And that led operators in an auction with just 300 megahertz on offer. And it turned out to be a 4-player auction with a new player. And that had then the consequence that no longer these industry recommended 80 to 100 megahertz per mobile network operator could be offered to each of those. So it's quite some fierce bidding, high auction proceeds, and some operators left with substantially less than these 80 to 100 megahertz. And that translates also certainly into less capacity per base station, meaning higher cost for a certain given capacity just because of the lack of bandwidth. So this concept had been quite heavily debated. There are quite a number of licenses now in place also for the local enterprises, and quite some proof of concepts and first real commercial network operations in place. On the next slide, I'll show the example of the UK. So the UK have decided to not offer any spectrum in this range 3438 directly to enterprises, but open up instead the range 3842. So that limits the ecosystem to this band N77, but still a very globally well-supported ecosystem. Furthermore, the UK offers access in a few other bands for such local licenses, like paired spectrum of 2 by 3 megahertz in the 1800 megahertz range, some spectrum in the 2.3 gigahertz range. And then also quite noticeable, they opened up first in Europe something in the 26 gigahertz range for local indoor licenses. I'll come back to millimeter wave spectrum towards the end of my presentation. So we now have 3 European examples. If we move on to the next slide, I also brought this US example where CBRS is often referred to as an example for access to spectrum for private networks. It shall be noted, however, if you really want licensed spectrum with its properties of guaranteed access to a certain amount of spectrum and so forth, you would rely in CBRS on such a PAL, priority access license. Those are issued and auctioned on a US county base, and there can be counties as big as Los Angeles counties with well over a 10 million population. So that's rather a regional licensing scheme but it offers subleasing options. So as an enterprise, you could talk to PAL license owners within your county, asking them for a sublicense. And within such a sublicense, then certainly, again, local enterprise networks, local non-public networks would be well possible. So if we move on to the next slide, so we see that variety of spectrum access models offered by regulators meeting their constraints, their policy targets. How can enterprises then actually look into it for deploying non-public networks? So 3GPP offers a number of options here. 5G ACIA, so this 5G Alliance for Connected Industries and Automation, as a trade association, as a body looking into how to promote 5G best within factory use, so mainly for manufacturing purposes, but also for process industry purposes. So they analyzed these models in a white paper, which I can recommend, and the link is given below. So there's a big range from this standalone non-public network, which may come first to the mind of people. So really just building an own network, maybe loosely connected with well-secured firewalls, also to a public network. But the full functionality of the network completely standalone in a factory, certainly then also requiring dedicated spectrum access for that. On the very right-hand side is another model. So using network slices of public network operators, just reaching maybe even from base stations outside of the factory or complemented by base stations within the factory, but completely operated and maintained by a mobile network operator, and then providing the required quality of service via this concept, 5G concept of network slicing. And then in the middle, there are models of shared deployments. So the interesting thing to share really is typically the radio access network with its base stations and the required control plane levels and so forth. Think of it a little bit like conventional radio access network sharing between mobile operators, which happens, for instance, in many parts of the world in rural areas. So one base station being connected to more than one core network and more than one mobile network operator. So here, one of these mobile network operators can be the local network, completely contained within the site with all its subscriber management functionalities, with all the core network functionality connected to a local radio access network. But at the same time, there can be the link to the public network of the mobile network operator, sharing these RAN resources and sharing certainly also the spectrum resources available on site. And then as a variant of that, even the control plane could be shared and handled within the mobile network operator network. So multiple options. And these shared models somehow remind me of the conventional voice PBX model, which may have become a bit obsolete in terms of dedicated voice communications nowadays. But think of it a bit similar like that. So like the local copper infrastructure within an enterprise, built and maintained by the enterprise, but carrying both the internal voice traffic from one desk to another, as well as all the outside calling of that enterprise via the public network. So on the next slide, I'd like to build a bit more on that thought. So whatever communications in the factory is here depicted in blue, but at the same time, the very same devices may have also connections to the outside world. So you may have the very time critical and time synchronized operation of robots, of automated guided vehicles and so forth. All sorts of machine-to-machine communication, but also certain office communication within the enterprise on kind of a logical blue layer of communications, purely internal. all data would be completely maintained and all communications completely terminated within the factory fence, let's say. But at the same time, many of these devices would have, for instance, remote maintenance functionality. There could be seamless logistic chains covering multiple factories along the roads, connecting these factories and so forth. Standard mobile broadband connectivity on these more reddish layers of a mobile network operator network. Now, within the factory, it's not necessary to build own coverage for those red layers. They could use the exact same factory inbuilt coverage from like small cell base stations, for instance, in the C-band range, for the internal communication. So again, somewhat referring back to that model of the PBX sharing the physical resources on site, both for the private communication, the company internal communication purposes, as well as whatever is required as connectivity to the outside world. Again, network slicing can be used both for network slices that are completely terminated within the factory, completely isolated from those network slices that come from a public mobile network operator network into the factory. So with this, we can move on to the next slide, where I'll try to explain a little bit on millimeter wave. So what are the motivations? So certainly for engineers, it's great to look into what technology can do with these multiple antennas. So spectrum efficiency can be greatly enhanced by adaptive antennas, really up to like beam forming in think of pencil thin and beams to individual users, creating additional multiplexing gains, so being able to use the same resource for more users and more traffic. But then there is a very simple lever, much easier to understand. So that's that there is just much more RF bandwidth available also in these high bands. So there had been design targets like greatly improving cell edges by beamforming. Then capacity-wise, there are quite some substantial gains possible. But then, let's say one has over roughly the tenfold RF bandwidths available over C-band spectrum. So coming from maybe these typical 80 to 100 megahertz carriers in the mid-band range to something like 800 megahertz or a gigahertz carrier bandwidth in millimeter wave. So that is a bare factor of 10 in capacity just from the RF bandwidth. So add that with spectral efficiency gain, so you can have like greater 15 times the throughput per base station enhanced, and that translates certainly into much lower cost per gigabyte. Now you don't necessarily need that countrywide, so millimeter wave is something more for real traffic hotspots, but factories may and will probably become such traffic hotspots with very intense use of radio, requiring very high bandwidth. If you think of specific use cases, like for instance, video production studios, wireless cameras with uncompressed video in very high quality for post-processing, require gigabytes or let's say gigabits per second capacities. So there are ample use cases thinkable with these kind of use cases for vertical use, for local industry use. So on the next slide, I'll look at a few licensing examples in the millimeter wave range. So we've seen very conventional auctions on large geographies, for instance, in the US. Japan, who also gave a spectrum to mobile network operators on a nationwide base, but more on base of investment commitments by those operators, also reserved a part of the 28 gigahertz band for local use. Italy took an interesting path in a sense that they offered 1 gigahertz of band in an auction, which resulted in 5 nationwide MNO licenses 200 megahertz wide each. But in order to come to these high bandwidths locally, they allow for what they call club licensing. So operators can join forces, can combine their spectrum assets locally to up to 1 gigahertz to really get these benefits from the additional RF bandwidth. Finland has taken an approach which resembles maybe a bit the one taken in Germany for the mid-bands. So as there is ample bandwidth from 24.25 to 27.5 gigahertz, they could offer 3 nationwide licenses of 800 megahertz to the MNOs and still reserve 825 megahertz for local licenses. Germany even decided not to offer any nationwide licenses at all, very much with the consent of mobile network operators, because also they very much see the need locally in specific hotspot areas, and those hotspot areas also then being orthogonal to the ones where industry use is possible. So there's little conflict expected, let's say little competition locally for the spectrum. So again, there is an application procedure in place with some similarities to the one in 3738 in the midband. Bundesnetzagentur here sees typically licenses up to 800 megahertz, but one could even with good argument get more than that in this local application procedure. Also, as a side note, even the spectrum access is considered more affordable than in the mid-band range. So, for instance, an 800 megahertz license in Germany for the very same area would cost the same like a 100 megahertz license in C-band, so a factor of 8 in spectrum cost. But as overall these spectrum costs can be considered quite affordable, that's probably not the big lever in the business case. The big lever in the business case really is the greatly enhanced capacity per base station where such capacities are needed. So to really make the price per bit or the price per gigabyte very affordable. So with this, I'd like to conclude on my last slide. So to sum up, I think this 4G, 5G technology clearly is now not only for this, what we all have for our smartphones, nationwide networks with great enhanced mobile broadband capabilities, but increasingly can very well address these non-public network cases. So a very wide variety of use cases being addressed. There are multiple options visible now in regulation, and many regulators still considering how to best address these additional needs, ranging from leasing within these nationwide licenses to explicit dedicated licenses directly to local entities. There is a big variety on the network architecture side, how to address that. From the non-public network architecture perspective, there are quite some choices of operating models, and I guess that's very much up to how critical communications are seen by a specific enterprise, how much they want to do on their own, and how much they want to actually have done by some mobile network operator for them. So maybe quite classical make or buy decisions depending on the priorities of the individual enterprise. And then I think we should not forget about the great benefits that millimeter wave spectrum can bring specifically to these local cases, and also resolving maybe part of these conflicts around mid-band spectrum where mid-band spectrum is scarce. Millimeter wave spectrum, certainly with its shorter ranges, also has this capability of being shared more easily in geography, so reuse becomes more easy. And then the key argument where needed, capacity really becomes very affordable. So with this, I'd like to conclude the presentation part and now lead over to our Berlin demo lab, introduce Matthias, who will show us a little bit how things really look then on the ground and how use cases can be seen. Thanks very much, and over to you, Matthias.
Yeah, thank you very much, Ulrich, and a very warm welcome here in our Berlin Demo Lab, especially in our studio. So my name is Matthias Hensel, and I would like to welcome you here and guide you a little bit through our demonstrations today. So as you have heard from Ulrich already, he spoke about the spectrum and the spectrum efficiencies and all the things related to the technology. And I would like to guide you, as you can see already in my background, how the reality might look like either for you or for your customers. So therefore, as you can see next to me already, our demo lab is providing a couple of things regarding enterprise and other solutions. And for that, I would like to go first of all into some slides to pick you up and show you the differences between the technologies. And as you might know, in companies and enterprises today, there is a lot of technologies already you could use for your interconnectivity. So for sure you have Tetra networks with high security, you have Wi-Fi networks which are giving you today already a lot of capacity but no reliability. Then you have LoRaWANs and Bluetooth connections. So a lot of technologies connected the industry today already, but not with the focus for OT technologies. So therefore we have the IT where you have 4G already, or maybe LAN and Wi-Fi connectivity. And then it comes now to business critical applications where we would step in now with our 4.9 or 5G technology to get the mission critical applications also on the wireless solutions running properly. And with that, I would like to show you the two main differences in the technology. So one side, we have the digital automation cloud, which is especially designed for small companies, but also for mid-range companies. And we have the modular private wireless solutions with a lot of technology on your side, but also with a lot of capabilities giving you as a company to do this. And then on top, for sure, certain things we can add on, like running on multifier technology. That means running LTE technology on top of unlicensed bands. But with this short introduction, let's come back to the studio and to the, let's say, systems itself, which I can show you now. So as I just said, we have these two differences between the technologies, and one was the Nokia digital automation cloud and the other one the private wireless solutions modular based. So for sure, first we will have a look into this automation cloud solution, which consists of an access router, and I think you have seen that already in our first video we showed. For sure it has connection towards the internet to connect to the cloud core elements you might need to run your network. Then we have the connectivity towards a radio access technology. We have one port which is connecting the intranet, that means your company network, and then also one for the edge cloud solution. So the edge server for sure necessary to run all your applications, the services you need in your company, and run them smoothly and fast into your network. Then from the edge server itself, we have the radio access, in our case LTE baseband, or say LTE small cell. From the small cell going into a modem, in our case an LTE modem, and from there we are connecting here in our showcase a security cam. So with this parts running already, so let's say the boot up time all in total is round about 10 minutes. So I will not do that since we have only the 10 minutes to show you everything. So 2 to 3 minutes for the router, for sure 2 to 3 minutes for the edge, and then radio access comes on top, plus modem connectivity took round about 10 minutes to run. But let's have a look into the dashboard and the capabilities. So what you can see over here is for sure once the security cam, that is the end user perspective, and then we have the dashboard itself, which shows you all the necessary information for your network. So for sure we have how many edge nodes we have connected and how many access points we have connected, the current network speed and an average, let's say how much uplink and downlink we have. Then we can also configure certain capabilities in the network, and that depends for sure on your capabilities, what is really necessary for you. Do you want to provision your SIM cards on your own? You want somebody else doing that, so it's not visible over there. You have the capabilities to configure the services, but also, for example, put certain quality of services into your network. So running a certain service with a certain quality over your network, and that can be done configured either by you or by somebody maintaining the system. But for sure the flexibility here is, let's say, a little bit restricted, but at the same time the costs for maintenance are a lot reduced. And as this is especially for those companies, for the smaller and the mid-ranges, as I said already, for sure you can scale it up also for campuses and bigger campuses. But if you don't want to deal or you don't have this high security restrictions in your company, then this is for sure the solution you can go for. The other option, let's say, from the digital automation cloud perspective towards the modular private wireless solution would be this one. So that means all of the technology, that means everything is running on your premises. And that consists of the servers we are running for the core elements and also for your application and services on top of the radio access. So for sure this is only cold hardware, but since our demo lab is equipped with such a network, because as you have seen, the AMR, the robot and everything we have over here and what we test and do is connected with our network. And therefore I would like to show you what we have in our basement. This is our let's say core element and everything what is running there in our data center, plus on top in this case a 5G standalone system, but we decided to run all systems at the same time, and this is Nokia unique. We are running a so-called co-op mode network. That means we have a 4G, a 5G non-standalone and a 5G standalone running at the same time. So why do we do that, right? So everybody is talking about 5G, but why is it still so much about 4 and 4.9G in our case? Well, that is due to our ecosystem around us. So we have a lot of customers running still like this smart vest on 4G technology, giving sensor information of the vest towards the network, but at the same time the industrial grade solutions like the Rexroth Nexo screwdriver, LTE connected as well. First of all, for sure, in pandemic situations when you have to, let's say, prepare your infrastructure company a little bit better for breaks of the supply chain. That means you can update screw profiles onto this screwdriver on the fly and at the same time gather all the information necessary for your quality assurance. And for sure the systems for mining industries, routers which has 4 and 5G connectivity, but at the same time enhancing your IP MPLS network towards the edge with wireless technology. So with all this together, we have quite a huge ecosystem already. And as you can see with this technology, modular private wireless, you have the capability also to control everything on your network. And everything means also security based, right? So all the data stays within your premises and stays with you, while the smaller solutions like the digital automation cloud solution will always have a certain amount of core elements within our cloud solutions. So from here, I need to close already my presentation, and I hope I could give you an introduction on the technology and the capabilities of modular private wireless. I would like to ask you, yes, for now let's go into a question and answer session together with Ulrich, and we hope that we are able to answer all your questions you put in the chat. And let's have a discussion about these things. So Ulrich, I hope you can hear me.
Thanks, Matthias. Very well audible. I hope also for our audience, and many thanks for that very interesting insight into what things mean then in reality, where I'm more on this spectrum management and policy level. So we have time for some question and answers, and some have come up here already. So feel free to post questions in the chat, and then we can try to address them. So far, they seem to go a bit more to my side, but also feel free to ask about the demo if there are any questions. So maybe I start with one question saying, in your opinion, should APAC countries be dedicating spectrum for vertical uses? Which of the models that you outlined from different countries do you think would be most appropriate to use? That's a very tricky one, and I think there is no general answer to it, as countries have quite some specifics in terms of legacy use of bands now being repurposed for 5G, in terms of how many operators compete for the spectrum from the conventional mobile network operator side, and then what kind of use for local enterprise is considered and looked after. So I think it's not up to a company like Nokia to give clear recommendations in one or the other side. There are different models that need to cater with these requirements, like really allowing mobile network operators to get access to these round about 80 to 100 megahertz of usable spectrum per mobile network in these mid-band range. Just to provide them with the economic efficiency required to bring services to the people in the end at affordable rates. And then at the same time, certainly enterprises need to be looked into. Are there possibilities for sub-licensing, or if there is ample spectrum, is there a possibility to assign spectrum even directly to them? Regulators should certainly look at the overall spectrum efficiency and efficient use throughout the country. So I don't envy regulators necessarily making these decisions. And maybe that leads also into another question here on the economic options. How should spectrum be valued and allocating with local licenses? I think our general opinion is spectrum prices should not be seen as something to increase the income for the treasury of a country. So auctions are the means to assign the spectrum to the economically most efficient use. So that's the idea in theory, but not to maximize the revenues from an auction per se. So spectrum fees for local enterprise use, if assigned directly to these, should also be very affordable. It's certainly a certain control element in terms of that enterprises do not hoard spectrum that they don't need. So there should be some price also to enterprise spectrum based on the time they intend to use it, but well, with certainly long planability. And then on the other hand, to the amount of spectrum, so that they really consider how much they need for their use cases. So again, maybe no crisp answer to that for regulators, but maybe giving some guidance of what criteria could be for that. Then I see another one here on if we see an interest from enterprises to conduct trials and launch their own use cases on millimeter wave. Yes, I can report from a few cases, for instance, in Japan, with a industrial automation company, we looked into robot control in factories in the millimeter wave range. Maybe C-band plays the more important role at the moment, still with these proof of concepts and these first real commercial use cases. Many of these are, for instance, like tracking tools, like programming tools, as you've just seen this screwdriver, tracking also materials and even the people. So to make sure in a factory, everything which is needed for a certain production step is carried together. Those do not necessarily require huge bandwidths and can be easily even implemented in 4G. Many of those can implement it on 5G in the mid-band range. But we start seeing those cases that really require also the millimeter wave performance. And maybe Matthias, you can share some insights if you see millimeter wave cases from your perspective.
For me, it's the same. What you have said already, Ulrich, is where you really need a dedicated or a huge amount of data traffic that is also seen in our automobile industry at the moment. When you upload, for instance, a huge amount of software data, which is at the moment still done via cable. So especially when it comes to software for each and individual car, which is done still cable-based at the moment, but that is, let's say, they want to transform that into a reliable software upload through the air, and that is where millimeter wave comes in place as well. So it's a dedicated, you need a huge bandwidth in a certain moment in a certain area. That is what I see at least already for the millimeter wave, and that is what we are testing already.
Thanks for that. Maybe a more general question. So why licensed at all? Isn't there a huge unlicensed world as well? So what we hear from our customers is that there is a need for this, well, guaranteed access to the spectrum resources in order to be able to provide certain quality of service. And I think that's the very big theme. If you have schemes that require listen before talk, you obviously cannot easily meet latency requirements. We had reports where use cases implemented on Wi-Fi had issues with handover performance. So because Wi-Fi is not really a mobility system actively supporting handovers, I think those are these key arguments. How can certain quality of service be guaranteed? And that leads into this requirement for some access to, in some way, to licensed spectrum, where you basically, at least for your premises, you have that exclusive use of right of use and can just immediately access the resource without any waiting.
Yeah, actually, it is exactly what you can see next to me. The AMR next to me is one of these use cases where it comes to reliability at the same time as we need handovers, because the AMR is capable to drive even though within elevators and somewhere else, and the fleet management needs to know where the robot is in a certain moment, and that requires handover scenarios quite a lot. And that is what we have tested with the MIR 100 here as well.
Great, Matthias. Thank you very much. I guess we're coming very close to the end of this showcase session. So I'd like to thank you very much for listening into that. I hope it was useful, also from maybe a more regulatory perspective, to get a glimpse on what happens. So with this, thank you very much for joining. Have a good day, have a good conference, and hope to see you somewhere soon in a real conference soon. Thank you very much. Bye-bye.
So also from my side here in the Berlin Demo Lab, thank you very much and hope to see you soon. Bye-bye.